Ladies and gentlemen, please welcome CTO and Chief Architect, Platform Systems Division, Juniper Networks, David Ward.
Good morning, everyone. Good morning, everyone. My name is Dave Ward. I'm from Juniper Networks, as you just heard. And I've been developing and designing routers, routing operating systems, routing protocols, and interfaces to program routers for about 20 years. Some of you are now really, really excited because you always wanted to know how to build a router. Others might be asking, why is he talking to me? And so I'm going to answer that over the course of my conversation with you today. But really, I wanted to start off and let you know really what's happening. And what's happening right now in the networking industry is that programmable networks are, in fact, safe for work. What I mean by this is that you are clearly the developers out there, and I'm up here representing the Internet itself. Both are extremely popular, as you might have noticed. What's interesting, though, is that there's a divide between us. And the divide between us is there because you aren't using information I can give you, and you aren't programming the Internet itself to provide the experience that you want to have for your application. These applications can be anything from the enterprise apps that you write, social media apps on mobile devices, whatever the case might be. You're optimizing for experience. I'm optimizing to connect everybody to everything. What's new about the situation is that there is, in fact, a new lottery ticket available for application developers. And that lottery ticket is actually going to be using the new information that's available that I'm going to tell you about today. I go about, and I was walking around the exhibition hall, and I see a lot of analytics companies out there presenting how to make applications work better, how to do operations and management to understand if the app is up. And this is all very, very interesting layer 7 and above type information in an OSI model. Sorry, I'm a networking guy, so I still will talk about the OSI model. So what I'm trying to say is that there's critical information that a lot of systems groups are trying to do about the application. But what's interesting is that there's an extreme amount of information all the way down to the capabilities of lambdas or wavelengths inside fibers that you can use to build a better experience for your application. So it's really beyond just the way the current architecture is working for your applications or on the Internet. Right now, applications effectively blindly probe the network, trying to understand what the experience will be, what the network can deliver. And I'm talking about not only gaming ping stats or checking in location and social media networks. These are all different ways to abstract what a user is doing with their application on the network. Towards that end, the network is also doing something extremely similar, except we're doing it differently. We do deep packet inspection at edges and borders of the network, where there's entire sub-industries or entire industries within the networking world that are doing nothing but trying to figure out what your applications are doing on the network. Now, they're trying to do it for a couple of reasons. Clearly for security and making sure that somebody has access to the virtual desktop or application suite or database information that they're supposed to have access to given their user profile. But in addition to this, we're also trying to figure out DDoS attack prevention. We're trying to figure out if there's spam or malware going across the network. And we do this by actually creating application signatures that are programmed into the forwarding plane of routers and switches to derive whether somebody's doing corporate email, personal email, surfing the web, or whatever the case might be. What I'm trying to lead up here is that the network awareness and application space is really, really immature. And the way that we're going about trying to figure out what applications are doing on the network is equally complex. So how to ensure the best experience for our users and the users of your applications? So first of all, it's really realizing that there's 4 actors involved in this particular equation. There's the end user who knows what they're trying to do. And the rest of the system, as far as they're concerned, maybe just to get out of the way. But what I'm trying to describe this morning is that the rest of the system is going to come together to be able to create the experience that they're looking for. Second and third, as related, are the application they're trying to do. And again, this can be any of the enterprise applications that you're building, working on the Oracle database tools, or any other application that might be underway. And then the last one, of course, is the network. And the network is going to tie all of these things together. And so it's the relationship of these four elements that is going to move us to the next level of building experience out of our applications in interaction with each other. So let's spend a quick second discussing why networks and applications actually need to work together. So what's interesting is that there's been a number of luminaries out there that you can read about in the trade rags that describe how we're at that pivotal point where in the cloud, the location of hypervisors, storage, I/O, and the overall guarantees or service level agreements that somebody's going to get out of their cloud need to be able to get to the point where there's an interaction between compute and storage and the networking I/O. And so we're at that point now, and there's been a number of folks who have written about this. Simon Crosby is one who wrote XenApp and sold it to Citrix. And really the key point is that folks who are working in the cloud understand that they need VM mobility, that they need storage mobility, that they need to be able to burst from a private cloud to a public cloud, or from a local cloud to a central corporate compute center. And they need to be able to do this and interact with the network because we have to carry the addressing, the state, the QoS, or quality of service, to guarantee that service level agreement is going to be met for that particular application running in the cloud. So let me describe to you next really what's new about what's available. First, what's new is that the application world has a number of new touch points and interfaces that it can use to directly program the network. And I'll describe these in just a moment and talk about them in a bit more detail. Next, the network now has a number of new APIs that are available to actually extract direct topologic information, location of content, carrying application information in routing protocols that flood to each node without breaking the internet. And I'll describe those to you in just a moment. And this kind of all comes together in what I'm describing as network programmability through a number of these new touch points, as they're called out here. They're called out here in the abstract, but it really comes down to an end-user identifier when they log on to a network. You can think of this as 802.1.x on a wireless LAN. You can think of this as your login as a subscriber in your home DSL. You can think of this as a logon from your mobile phone to identify yourself. Each of these end-user gateways builds a service-specific profile for you, the user, and the application suite you may be running. Traditionally, this wasn't available to be programmed to, but again, this is one touch point that is. The enterprise edge is really at that enterprise edge router where it's extremely challenging to get the exact balance of security, performance, delay, and jitter out of the network. But this, again, is now a new programmable point. Hypervisors now are programmable through CloudStack, OpenStack, and various other security mechanisms built into the hypervisor. Again, those profiles are fully programmable that you now have available to your applications. Rounding it around, and we'll talk about this a bit when we talk a bit more about service providers, the actual billing profile. Again, in telephony, an entire industry has been created called application-based billing, where as your mobile internet traffic is coming in off your mobile phone at that mobile gateway, we're sniffing using deep packet inspection and stateful flow analysis to find out exactly what is traversing over that 3G, LTE, et cetera, IP network, such that direct billing buckets are there for you, the corporate user, or you as a general internet user out and about town. Continuing to come around, the notion that we're using secure gateways to land either off our mobile phone, off our laptops, off of our tablets, or whatever the case might be, is now a critical new place. At this point, think of it this way. You're access technology agnostic. You're coming in over a tunnel that's identified only by you. It's only running the applications that you're allowed to based upon the security profile that we understand coming in off that gateway. This is, in general, a form of telemetry about the user using IFMAP, for example, but it's telemetry about the user, who they are, what device they're on, what operating system they're running, what applications are running on that device, and then based upon what access point or access technology they're using, gives them direct access to the applications you're writing, virtual desktop suites, storage, etc. So, for example, if I'm here in San Francisco and I happen to be a trader in Wall Street, I would not have access to the trading floor, just to keep it perfectly simple. Now, the last example I want to discuss, and we'll discuss this in a little bit, is about content data networking. When you want to place adverts, data, if you think about problems as distributed data cache issues, where folks are attempting to go after certain data repetitively, or there's groups of people going after the same data, or there's groups of people you want to get the same data in an advertisement type form or a video injection type form, being able to place, identify, modify that content that's going to be provided to them is extremely critical. And that's what content data networking is about. Yet another API and mechanism for you to program directly to the network to deliver the experience that you want. So what is possible when doing this? Well, I went through a number of different examples of how I hope you understand how this is directly relevant to you. But really, it's that you now get direct topologic information. You get information about the bandwidth and utilization about the network, such that you can deliver between, again, high-definition video versus standard-definition video. You can do real-time streaming video, or you have to use something text-based. Either way, really the point is that you now get exact information that you can build into your application and the application responsiveness that you need out of that application, gaming, financial trading, database analysis, any type of point-of-sale transaction, and have this built directly into your application. And towards this end, as I alluded to in the last slide, the touch points are critical that you can program. So if you think about the suite, and I've been at this a long time, and it's acronym soup, there's been radius, diameter, COPS, generic switch management protocols. There's been SNMP. There's been DHCP-based configuration. These are extremely old-school ways of programming profiles into networking devices. The industry has realized over the last 8 years that it needs to change the manner in which innovation can be done to create these specific profiles. Talking about it from a networking point of view, if you think about traditional voice, video, and high-speed internet on an access link from an enterprise or from any particular end user, it's that high-speed internet, that catch-all category that now is being programmed, modified to reach or enhance specific service profiles that are being desired. Because that high-speed internet, even in an enterprise network, represents all database and mainframe traffic. It represents all internal email. It represents everything that isn't voice or video. And so that's why it needs to be very, very specifically tuned and programmed from the applications that need to have a certain service level agreement. So let's talk about how these actually come together and how this is actually going to work. So I mentioned earlier that applications are deriving information from the network. There are proprietary control channels that currently exist in variable bitrate video exchange information, trying to scavenge bandwidth that's available on the network and greedily going after whatever is available at the peril of another application that's attempting to do the same thing. So this is absolutely the greedy model of application programming, but that's what's out there. We've got GSM coordinates, which are moderately entertaining if you actually want to find out how to drive to somebody who you may be talking to, but it appears to me to be almost completely irrelevant to the type of experience that you're going to have in understanding what's around you in the rest of the topology of the network. Other things are check-ins and traceroute databases, and we'll talk about those in a second. We've already mentioned how the network is spying or trying to understand users. We talked about deep packet inspection, capturing net flow, which is a form of collecting statistics, as is IPDR, which is the reason why it's interesting, and I'm calling out an acronym of IP data record, is this is the mechanism that's used for volumetric billing information, for example, on your home access link. Almost every provider is using this particular type of data record to understand when you're within a bandwidth threshold. If you as an application developer had access to where you were within that thresholding mechanism, with that threshold level, you could write an application that keeps you right below that threshold, and experience for that user will not get exponentially worse because you accidentally crossed that threshold. So now how is this going to work? And I'm fair warning now, although it's early, we have a few acronyms on the other side of the slide, and the next slide's a little bit more complex, so spin up the twirly hat because we're going to go for it. What we have between applications and networking coming from the network are ways and protocols that are standardized. This isn't Juniper proprietary, but these are standardized protocols to dynamically signal paths from application space. GenApp are extensions to IGPs like OSPF and ISIS, which are used to define and route within the topology of an enterprise or service provider that can flood application-specific information. The type of information we're talking about are, I have a service appliance like a NAT or a firewall at this location. I have a content cache here. I have part of a database in this particular location. My server load is X. My bandwidth utilization for this particular service is Y. We can now flood this to specific devices without actually affecting how the internet is working, because over the last 8 years in routing protocol space, we've segmented out critical routing information that we need to keep the network up from other information that we can carry around and program directly into those networking devices. I'll come to the point on provider-based development platforms in just a second, but the last pieces at the bottom are ALTO, the Application Layer Traffic Optimization Protocol, which again, nice acronym. They should be 3 letters, but it's 4 in this case. It's a nice acronym because what we're trying to do is give you direct information about the location of a user to a bit of content or database or service that it wants to go to, and use proximity to that content cache, as an example, from that user and where it's in the topology. So now an application can bias which cache, which server, which database, which bit of storage it's going to use based upon proximity to it on the internet. That proximity can be not only shortest path via router nodes, which is moderately entertaining, but what's most entertaining is if we add in the extensions that we've made to include delay, utilization of that path, jitter of that path. And so now, again, you can stay away from going halfway around the planet if that was currently the way the internet wanted to route you. Your application would program the internet to take a different loop-free path through the internet to get to the exact service that you wanted to. Okay, how do we make this happen without breaking everything? I've already alluded to the point that we've segmented our routing protocols such that we can pass routing information and we can pass other information. We've done this through creating multiple instances of the protocol. We've created new TLVs. This has been, new packet types to be able to pass this application information. And we've been doing this over the last 8 years. And I realize this, we might not have come earlier as networking folks to come talk to application folks, but we have been doing this for a while in the implicit understanding that if we begin to build this ability to program into the network and application developers take advantage of it, the experience will be better for both the network and a higher quality network experience and a higher quality application experience. So in the network world, as I described just recently, we've built up using these new protocol extensions. We talked about application layer traffic optimization, path computation, et cetera. You might have heard about OpenFlow as well to program data centers. But really, you don't see these APIs that we've built into these protocols. They're hidden from you. And they're hidden from you because you're used to developing, obviously, or programming to specific development platforms. And there's a zillion different development platforms that you can choose from. There's a bunch that you can take a look at the exhibition hall, and there's obviously a zillion that you've been coding to so far. The point of what I'm trying to say is that the more you know about what's going on below those development platforms and how they're interacting with the network, you're going to be able to do more than just get an IP address or get a domain name, which is what you might be able to do with the current language that we're working with, and instead program the nodes themselves, get topology, get delay, get utilization, and program QoS profiles for your application. And towards this end, coming from the network is real-time understanding of the topology. Going into the network from application space from you is steering traffic through particular optimal paths, selecting specific traffic by building application-specific classifiers into the forwarding plane of these networking nodes at all of the perimeters of the network that I introduced you to earlier and that are listed here. So let's focus on really what you're going to see, which are these orchestration or development platforms that are a level above the protocols where I work. So really what it comes down to, on a fairly vanilla way of saying this, is that generally I'm going to sum it in these four categories. There's operation and billing systems. There's new network function-specific development APIs that generally work with the network, which is unified communication. Maybe you build applications doing that. Service-specific, which includes sensor networking or CDNs. And then these new provider-based development platforms. So I'm going to talk a bit about the last one in particular. But these four different types of platforms get extremely confusing to tease apart in the trade magazines. Right now, if you watch the blogosphere, you're going to see, like bugs to a light, new shiny objects become very, very exciting. And there's lots of new shiny objects continuously coming out from development platforms, obviously, as well as from the networking world, as well as from application space. The key thing to remember is that the development platform you choose for the type of application you want to build 100% defines the customer base and direct market that your application has access to. And so that's why you need to understand what's going on at the development platform level and then below in the network so you understand what you have access to build the highest quality application with the highest quality experience that you can. So let's talk about that last category for a second. If you take a look here on the peninsula and around the planet, there are a number of these service providers and a number of others have all built application innovation centers here in the peninsula in the Bay Area. What's interesting about this is that when you take a look at the customer reach that you have access to, when you take a look at all of it, as you're reading here, you're reaching over half of the world's population and 2/3 of the world's GDP available by choosing the correct development platform to code to. I'm not saying that these are guaranteed, the winning lottery ticket or anything like that, but because these are emerging, it's really a call to you to pay attention to what's possible and to make sure that you understand what's going on below in the internet, underneath going on in the internet below these platforms to be able to make the best experience possible. So let me give you some examples of exactly what I'm talking about. So I'm going to start at a high level and give you exactly some work that we've done. So in content request routing, I want to go get a movie. What we have available now is from where the user is connected. I use my application layer traffic optimization. And when I come in with a request, when I go to DNS, which is the domain name service, to say, I'm looking for xyzmovie.com, that domain name service actually takes input from where you're coming as a user to where that movie's located in the network, and then finds the closest, least utilized location for this to happen. So the new application will use this information directly from the network infrastructure. This can span multiple providers in what we would call Content Data Networking Federation, which is another popular topic on how to span multiple providers with a single database or single awareness of data and object location. And as I mentioned, you base this upon network proximity, availability, congestion, whether the content's there, et cetera. And so we're headed down this path. So let me walk you through this exact example. So we've got users in New York, London, and Paris, and they want to get data that's located in Chicago, London, or Amsterdam. I talked about the name service as one way if you're using a name to go get something, but of course this can be built with a web plugin directly in the browser that the user might be using. So the user comes in from New York and says, where's my content? The network's going to say, hey, here are the closest data centers to New York. If you combine this with service-specific information, which is where is the content located, what is the load of that content cache, how many connections does that content cache have there? And I realize that this example may seem absolutely obvious. Isn't this just the way it works now? And really the answer is no. This is the way things are beginning to work. We don't have these feedback loops. But let me continue. So now we've handed back the information from these media content servers. And we've built a per network answer for that particular user. And so when they ask their question, where's my content, after merging this two information together of topologic information of bandwidth, location, as well as server, the answer is Chicago. Now, being from Minneapolis, Chicago is rarely the answer, but in this case it is. So bandwidth calendaring is another example. This one, I think, is directly applicable to anybody who's working with databases or large amounts of content that they need to distribute around their network. So what do you use this for? If you need to push something, you want to schedule that push in the network when the bandwidth is available. If you need to do a data center backup, you want to schedule when 10 to 100 terabytes of data can actually traverse that network in a loop-free manner that meets the overall requirements that you have for either delay or bounded transmission of that data. So you schedule a reservation for the path using priority in either a waterfall or bin packing algorithm, which means either make the traffic fit or move traffic around such that it can fit. And we give a particular answer out of this. And the key thing is an application doesn't have to derive or intuit the topology of the network or what's going on the network. A server that sees this information, that's a development platform that you would code to, would be able to do this for you. The last example is on social networking. And location information and social networking mobile apps has been a huge topic going on recently in the RAGs. But what's interesting is that all location identification information in social networking is really an approximation of that end user. That approximation of end user really comes up in various different types of development platforms that give you analytics or gaming or advertising or commerce or communication. Then the amount of VC money going towards these development platforms of these different categories is immense based upon location ID. But what's really interesting is they all are built off the application intuiting the information about the network. Instead, it's absolutely possible, because the network holds this information at the touch points that I described. What type of access technology? It knows when a user's been mobile. It understands when there's congestion in bandwidth or in utilization. It understands network location, et cetera, and can build the information and tell an application when to switch from real-time streaming updates directly to that mobile application or real-time advertisement or using real-time video to switching back to use the more traditional where am I and check in. So really, trying to pull it all together, the main architectural constructs that are being used today in trying to identify where and what something is in a network topology are based upon three general constructs. You're either above the topology and giving analytics about the over experience. You're either visualizing the topology, where you're basically doing geo-coordinates and building maps out of this and draping where the gas stations or various other food outlets are that somebody's looking for. Or you're below the topology in an operating system trying to hide this from the application developer, but yet binding them to one particular set of development tools. So I'm not talking about those. And I'm not talking about active broadcasting or checking in. Instead, I'm talking about a notion of being in the topology where the network's going to say, you are here, and you have this amount of access, capability, bandwidth. And these things are around you because they also have been identified in the network with their device capabilities and the network capability to reach them. So I realize that I'm far below the general application layer of is my application up or not, and instead feeding you information and allowing you to feed me information as being the network to improve that experience. Pulling this together, just to make sure you're still with me here. So really, what I'm trying to say is that the combination of this data through multiple development platforms, through these network APIs, are going to give you the new capabilities in your application programming environment to build a better quality of experience. The other thing that I wanted to mention is that really these decisions of the types of networks and the types of network programmatic platforms that are going to be available are being made by IT, enterprises, service providers, operators, etc. And as an application developer, you must feed that well and say, I need this type of information and I can deliver these types of application. So This really isn't a game of lottery. This isn't who can come up with the best ping stats or can I build a rapid deep packet inspection mechanism to find out what you're doing with the network. This is really applying skill and information that we know and programmatic capabilities that we have to build better networks and better applications. We can enhance those applications. And so, being from Juniper, I'd like to mention that these are places you can get more information. And in addition, you can also drop by our booth and get more information there from some of my colleagues. Thank you very much.